Hello everyone, and thank you for attending today's webcast, Inventor HSM Turning. Our presenter today is Tad Whitchurch. He's the Director of CAD/CAM Training and Support with Hagerman & Company. Before we get started, I'll let you know that you're in listening only mode. If you have questions during the presentation, you can type them into the question panel on the right-hand side of your screen, and they'll be addressed at the end of the presentation. And as we close down the session today, you'll be prompted to fill out a survey, and we do ask that you take a few moments to fill that out. Additionally, all registrants will receive a follow-up email containing a link for the recording of this presentation. And with that, I will hand things over to Tad.
Well, thank you, Ashley. Hello, everybody. Thank you for taking time out of your day to visit with us here. We've decided to do this presentation on the Autodesk CAM solution HSM on the turning application. As we scan through the web and through other presentations, we see milling everywhere and not a lot of turning. So we thought we'd spend a little time and maybe just focus specifically on the turning side of things today. The other webcasts that we have, I do want to mention to you, we have a list of HSM webcasts on our Hagerman.com website that include milling applications and so forth. And I'll show you that a little bit later towards the end, depending on time, because I wanted to introduce you to that if you haven't seen it. That Hagerman & Company has a slew of helpful webinars on our website that are available to you on demand when convenient for you. Now, again, focusing on the HSM turning, this presentation will be in the Inventor solution. Although what you see today also does apply inside the HSM solution for SolidWorks. Just an introduction. If you've sat through a few of our webinars already, you might be bored with this, but I do like to bring it up every time. Hagerman & Company is an Autodesk reseller, one of the largest privately owned Autodesk resellers in the country, with offices California, in the South, Midwest, basically throughout North America. The reason I bring this up, and I won't spend a lot of time here, is that I do want you to know that we have experience in manufacturing, and specifically CAM, or computer-aided manufacturing. A little history is we started out with Smart CAM and SDRC Ideas. You may have never heard of that. They've been bought out since. But in the early days of the Unix workstations, they were the head-to-head competitor of the Pro Engineer solution. Both of those we started with probably back in 88, 87, 88. After that, SmartCam dissolved, and we had a great opportunity. We went shopping for CAM systems, which is a little bit on the flip for us, but we picked up EdgeCam and helped a lot of our clients with their manufacturing solutions with EdgeCam. And now that new technology is always, just a day away, the Autodesk HSM solution for both Inventor and SolidWorks is what we're focusing on now. So we do have staff available that do understand manufacturing processes, understand the software. So we're here to help you with that. When we talk about the next generation of CAM, we talk specifically about the Autodesk solutions. There's actually, and I've mentioned it a couple times now, at the bottom there's the HSM Works, which runs inside of SolidWorks. Yes, we can sell that, and yes, we can help you with that. And then on the bottom right, we have the HSM solution inside Inventor. And cloud-based processing and solutions are right on our doorstep. The HSM functionality does reside in the cloud also with CAM 360, or some of you may have also heard of Fusion 360. So that does have manufacturing capabilities that are cloud-based. Why integrated CAM? And when we say integrated CAM, what we mean by that is that the functionality of the software, the CAM software HSM, is residing inside SolidWorks or Inventor. So you don't have to exit and re-enter. You don't have to translate data, export out, import in. Engineering changes happen, then you've got to re-export out and re-import in. This is why integrated CAM is really the future, and really shortens and streamlines your workflow. We don't need to do any more exporting or importing. Those days are gone. In fact, we don't even really need to define the setup, because the software knows that a change has been made, and you'll be flagged by that on the CAM side, so that you have to verify your toolpath and regenerate if need be. So we're really bringing down the steps that are required to go from an engineering design to chips on the floor. So the integrated CAM, I think, is the future, and one of the things that Autodesk has done and done right, maybe I shouldn't say one of the things, one of several things that Autodesk has done and done right, is that with the integrated CAM solution, excuse me, they have packaged with it the Inventor software. So you basically, when you go shopping, you have 3 different products on the shelf. You have the Express solution, and this is a free, fully functional CAM system. And I know that's kind of hard to believe, but the idea here from Autodesk is that they don't feel that people should have to pay for 2.5 axis milling anymore. So you can get the Express version, download it, and use it for free. Make parts, make chips, post-processors are included. The kicker there, since it's free, is it does not include Inventor. So you will need to have a seat of Inventor in order to utilize the Express version, Inventor or SolidWorks. And whenever you do the download, there'll be a couple links there, and you tell it what version you have. So you don't need to be in Inventor 2017. You can be in 16 or 15 and still use the Express version. Now, the standard solution, we call it standard, is you do have to pay for it, but it does include a seat of Inventor. So when you look at the price point, I think you'll be surprised. And don't ask me for pricing, because I try to stay as far away from that as I can, focusing specifically on the technical aspects. But your sales reps or let us know and we can get you that information. But from a price point perspective, keep in mind that when you look at the HSM solutions that are for purchase, both standard and professional, it does include a seat of Inventor. In fact, the HSM professional solution includes a seat of Inventor Professional. So you're looking at tube and pipe, cable harness, FEA capabilities, all that good stuff. So we're finding that this is a great package deal, because you can, if you need to add a seat of Inventor or Inventor Professional, you can go with the HSM route, get your seat of CAM, and start sticking your toe in the water, so to speak, and start working with the CAM solutions. So it's very popular, and especially for people adding seats that have a need for CAM. Maybe they've already got Master CAM or Gibbs or something like that, but you need a seat of Inventor. Get the CAM solution, start working with it. As far as the software and how to use it, one of the things we found is that the learning curve is relatively short, especially compared to the old days of EdgeCam and SmartCam, etc. We're running a lot of training classes that are really only 1 day in length. When prior to that with EdgeCam, we were looking at 2, 3, 4 days of training. And the reason for that is it is a part of your Inventor environment. Do you need to know Inventor to use HSM? No. Is it helpful? Yes. But it's not really required. So the user interface is really just a ribbon that you see up at the top. That's all the CAM adding to your Inventor environment. And then the process for creating toolpath is repetitive. Okay, you basically define a job setup, define your operation, simulate, and post, and it's just repetitive. Depending on the operation you're looking for, same old, just do these steps, which makes the learning curve really quick. So just to sum that up, we want to mention that, again, the experience we have, the Autodesk solution, HSM, they didn't build this from the ground up. Obviously, they purchased the software, so it is proven. It's been around for a very long time. And so when it comes to CAM and Autodesk, you know, think Hagerman also, because we are here to help you. Enough of that, right? So let's go and take a look at the software. What we're looking at here, and hopefully you're seeing it, is just a standard part. It's a round part, but it also has some milling in it. Milling operations, obviously, on the end. And then the user interface up at the top. You have the CAM environment. So your basic Inventor functionality is here. When you install the HSM solution, it adds this ribbon. So here's our learning curve. This is all that we need to focus on when we're doing training. Also, underneath the help area, there are tutorials that are available to you. You can go and browse samples that are installed with the software. If you want to, you can go straight to YouTube videos, and there's also a discussion group that a lot of people utilize for their questions. That's monitored by resellers like us and Autodesk also. And then, of course, the About button is kind of important. We do like to mention that this is where you find what software you're using and what build you're on, in case you have any trouble when somebody asks you. So again, the user interface is at the top. We've done several presentations on milling and so forth. So today we're focusing really specifically on this ribbon, the turning ribbon, and the operations that go along with that. Now, one of the things that come into play is that when your engineering people are designing parts and assemblies, they're not really too concerned about where a part might sit on a machine. You know, in fact, we don't want them to be, right? We'll deal with that whenever we start putting toolpath on it. So we do that by utilizing the setup. And what the setup does is it allows us to go in and define the coordinate system for the machine. And you can see Autodesk does a wonderful job as far as the user interface and helpful graphics so that you can see what it is that you're working on. And from a manufacturing standpoint for turning, my experience is that the z-axis is usually pointing in or out of the cylinder, and then X and Y are perpendicular to that. So when you go into the setup, the operation type is really the important button that you have to worry about, because we're not doing milling in this instance. We're going to do mill turn. It does also support multiple spindles, and we can get into that from a training aspect. And then your radial dimensioning. When you're turning, are you dealing with radius values on your G-code output or diameter values on your G-code output? So we can define that also, depending on the post. And then you define your coordinate system. So here we have the z-axis pointing out. If you need to flip that, you just click on the arrow and it flips it. Very easy to work with. Same thing with the X. You can also use these check boxes to flip if you'd like. And then where is the origin point? Is it in the front face or is it the back? Would you like to select a point? Or is it on the front of the model or the back of the model? So a lot of choices here for defining the coordinate system. There is an area here for model because the HSM solution does support assemblies. So if you modeled up your chuck and your spindle, you could have that on here. So you could be working in an Inventor assembly, and if you are, then you're going to want to go in and actually select the part that we're machining. You can define your stock either via a fixed cylinder, boxes are primarily used more on the milling side, but I've seen it used in turning also. And the stock is used to help determine the tool path also. So the stock is an important part of the setup. But you'll see your options here. Another option there at the bottom is from solid. So that if you have, and you deal a lot with castings that come in, if those castings can be defined as a solid in Inventor or SolidWorks, you could put together an assembly of your part and the casting, and then use the from solid option, pick your casting, and that would be your stock. Some length for the stock cylinder. You can define it via numbers, or just use, I use relative a lot, where it's just take my part and add, you know, 1/4 of an inch on the diameter and maybe 100 thousandths on the face. And then over here on the post-processor tab, not much here, but it is important to mention that it does support multiple work coordinate system, like your G54, G55, G56. You know, you just put a 1 in here for a G54, increment it by 1 for G55 and G56. So the setup is important to that. A couple operations to start off. We'll discuss the face real quick. It's very simple, but it does allow us to get into the tooling. But the face operation is used a lot, where it already knows where the front of the part is. So you really just need to go in, define your clearance planes, any tolerance. Do you want to use multiple tolerance passes? I'm sorry. And then do you want to leave stock on the face, perhaps to come back later and finish that? How do you want to handle retract in your rapid moves, and how do you want to handle the lead in and the lead out? Do you want it to be different? Do you not want it? Or do you want it to be the same? Now, looking at the tooling here real quick, there is a tool library that comes with the software, and it includes really just a boatload of sample tools, okay? And they're all found in different libraries. So these are your sample libraries. You can easily create a brand new library, you know, called my company name. Or another thing that I've seen used often is, you know, maybe steel or aluminum. And then the tool library is the same, but the speeds and feeds for those tools are different. So you can create your own library. Samples, then if we go down and look at the sample turning tools, just to quickly look at these. Again, Autodesk has done a good job with their user interface. And you can see here that it's tab driven. So the first tab is just general information about the tool, the number, the compensation value. You can use descriptions, comments, vendors. You can also turn this switch on if your machine supports manual tool changes, maybe where you want an M00 instead of an M06. The post will look at that and recognize that. On the insert tab, all of the basic inserts come with the software, where you can select an insert based on the information that you're familiar with, and it will update that accordingly. The type is a little limited compared to the milling side. It's not limited as far as functionality. The only difference here really is that on the turning side we can define form tools, you know, special shape tools, because we build a section and revolve it, and you have a milling form tool. Turning's a little different because the tools aren't revolved, so you won't see form tools on the turning side of things. But all of your standard tools are here. So we have your general turning tools. If we go to groove, the shape changes automatically. If we go to threading, the shape changes automatically, and boring, the same thing. So your basic tools are here along with your inserts. Your cross-section types are also defined and available for you, as well as these parameters that you can pick and just pick and pull. Okay, very easy to use. You can define the holder. You don't need to, but you can define the holder if you're worried about interference, collisions, etc. There's also the general tab, the type for the holder, and also the style for the holder too. So you can change the style very quickly to the holder that you're after. The hand, the definitions, and so forth. Is the shank round or not? Then we had the setup, basically based on the turret. So how is this tool mounted? Is it more for boring or for turning? And then the compensation, as far as your G41 and your G42, how do you want that to be handled? And then your spindle rotation. Here's the speeds and speeds, and these are defaults. So whatever you put in here, when you use this tool, those values will be defaulted over here on the left. So it's still your responsibility as a programmer to make sure, your setup and your part, is it a flimsy part or whatever. You're still in charge of the speeds and feeds, but the default is nice. And that's why I mentioned earlier that when we look at the libraries, I've seen it used where people may have, just a handful of libraries, and they might be named aluminum, steel, cast iron, titanium. The library contains the same half a dozen or a dozen tools, but the speeds and feeds in the libraries are different. Just a thought there. And again, this presentation, I've only got an hour, so it's not really a training thing that we're going through here. It's just kind of a high-level overview to hopefully either get you started or get you interested in the product. Because we are also going to be looking at live tooling and milling and the turning application, there is the milling tools are here. If this is your first presentation, you haven't seen these, just real quick, we have all of the different milling types that are available to you. I do want to mention that with Inventor HSM 2017, probing has been added. So again, when we get into the operations, you define the tool, and basically, again, from the learning point, you just move from left to right. You define the tool, any containment. This is a face mill operation, so it's probably not a good example. The clearance that you'd like to define for rapiding and getting into position. You control the passes. Do you want multiple passes or just one pass? Do you want the stock to leave? And then this linking tab, just keep in mind that's how you get from one pass to another. So how does it get from the first pass to the second pass? A lot of that is controlled in the linking. And that's consistent for turning any operation and milling also. So from there, we can just simulate that, and very quickly you can define your tool path. Okay. Now, other operations, that's the face. Profile is probably the common one, at least for profiling. The outside or even the internal part of a part where you can do like bores and so forth using the probing operation inside a part. So again, profiling, you select your tool. You'll notice that where facing was relatively simple. When we go into some of these other operations, we do have a lot more functionality. So we have mode and direction. Are we doing the outside profile, face profiling, or are we doing an inside profiling profile? And are we moving from the front to the back both ways or backwards out? The allow grooving switch is pretty neat. If I OK this real quick, you'll see that the tool goes right over the top of this opening. If I edit this and tell it to allow grooving, it's not too obvious here, but the tool path will dive down looking in at the bottom of the insert so that it's not gouging with the back of the tool. Your feeds and speeds, it does support constant surface foot, which is important to turning, especially if you have, you're starting with a large round piece of stock and you're going to make a smaller diameter. As you profile and go through it using constant surface foot, you can have it control the spindle speed so that you're still getting the same chip load as you move, and you could perhaps even increase your not only the spindle but your feed rate. Containment does apply here. If you don't want the operation to go all the way to the end, you can define a containment box back here, either with a sketch or picking a face, and then the profile won't go past that face. Rest machining is something you'll want to become familiar with. Rest machining, the term's been around for a while, but basically what it means is the software is looking at the previous operations so that this operation is machining the rest of the stock that's left over. So I typically use rest machining all the time because I want it to always be looking at what was done before. Again, we have your tab for the clearances and your retracting and your approach, the tab for passes. In the profile sense, we can do roughing and finishing basically at the same time. We can leave stock and come back perhaps and finish it later. And smoothing is important if you have kind of surfaces that work around the part. If there's a surface going around here, you won't get your GO2 or GO3. You'll get maybe just a bunch of GO1s or G1s, and your program gets long. You can play with surfacing, and it's looking at the definition of the geometry of the G code, and you can eliminate, especially in a roughing application, you probably could eliminate a lot of lines of code by increasing the tolerance. And then when you get into a finishing operation, you can bring that down tighter. And then again, make sharp corners where you just want to come up and over, or do you want it to go ahead and round out based on the nose of the tool. And then finally, your linking tab is based on how you get from one pass to another. Your lead in and your lead outs you'll find here also. Simulation is what I use a lot. Do you want to see the tool path and do you want to see the stock? From my perspective, I usually turn off the tool path, turn on the stock, and then down here you have a way to control the speed of the operation, and if you want to, you can even make it go backwards. Okay, it doesn't put the stock back on. It's not that smart, but still you use that a lot when you're getting into fine corners. And there the grooving is on. Okay. Another thing we can do with, like, here's a finish profile. One of the things that you can do that's really slick, and if you're an Inventor user, you might be familiar with this, is I can simply right-click on this and just say duplicate. And it adds all of that functionality that's in this profile right to here. And then I could double-pick this, change my tool, and hit OK. And very quickly change tools. Here I have grooving on, so I'm going to be able to maybe rough out more of that area with this type of tool. Don't know if that's what you want to do or not, but at least it shows well the grooving capabilities. And this guy right there, don't forget that. Take a screenshot if you need to. And okay, we'll go ahead and update the tool path for the finish operation. Grooving now you'll find that right up here. So we've got face, groove, profile. Grooving obviously is going to need a different tool, right? So we can look at those tools. I think I may have already shown you this. Yes, okay. Different tool types that you want to use for grooving. The definition of the reach, okay? And again, just working from left to right, what type of groove is it? Is it an inside groove or is it an outside groove? The direction, front to back, back to front, or both ways. And again, if you leave your mouse on these, and just, I think it's like a half a second or something, the help system is very good where you get some real nice graphical feedback on the choices that you have and real good help on which one it is that you might want to use. Okay? Both ways is one that I've used primarily. It just allows for kind of an equal wear on both sides of that grooving insert. Your speeds and feeds, again, constant surface foot's always a good idea when you're facing or grooving, because the spindle and feed rate will try to maintain the same chip load. Your containment, again, if needed, you'll see in this case I'm selecting the inside of this groove area. It's highlighted there in blue. Hopefully you can see that. So that when I'm doing the grooving operation, I want the software to just focus on this area in here. I am turning on rest machining from the previous operation so that it's looking and seeing that the top of this is cut off, which gives my approach a little closer, not wasting air or cutting air. Wasting air, okay. And also your clearances. Your passes, do you want it after the groove is done? Are you going to use this same tool to come back and finish it? And also you can control the roughing pass, or do you want to not do the finish pass, leave stock, and come back and finish it later? Your call. As far as the pattern for grooving, quite a few choices here also for the step down. On a deep groove, you might want to do a partial step down or even a sideways sort of thing, and there's the full step down also. And pecking too, depending on your operation. You need it to break that chip and then continue down and break the chip. That option is available also. So we'll okay that. We'll roll the wheel the wrong way, which I just do all the time. And we'll simulate this for you. And this is neat here, like where I mentioned you can back up. We come over here, right? And then we'll finish it off. And away we go. And editing is just so easy that I could go in here now and we'll run over and maybe change the grooving pattern to sideways with partial step down, hit OK. The operation is now completely different. And for something like this, that might be better, but you are putting a lot of wear and tear on the nose of that. But again, from my standpoint, I typically pick the operation I want, the tool I want, go through the forms, fill in what I know, pull the trigger with the OK button, see what I get, and then come back and start editing it and tweaking it in. I'm just going to tab over here real quick and see if we have any questions. How do you pick a face for containment? It really should be as simple as your mouse, but let's run through that. If I zoom in here. I don't have a one of those fancy mice with me, so this X will deselect what I have. As far as picking containment, as long as the checkbox is on and this is lit up, your mouse should just go out here and select, allow you to select faces. So it should just be a mouse-driven thing. If that's not working for you, let me know, though, maybe via email or something, because that should really be all it is. Pick on the setup. I'm going to go here to Tool Isometric and get myself resituated. Drilling and turning. Yes, we can. Now we're kind of stepping into a little bit of the multi-axis stuff. From a drilling standpoint, we can do holes, and so we've moved away from this turning ribbon over here to drilling. The only kicker here is, once you pick your tool, when you move to the left tab, you want to make sure that the tool orientation is set up right. And I intend on showing that to you later, really kind of from scratch, okay? And you can select the hole faces. If there's multiple holes, you can turn on this checkbox, like this flange around here, and it will automatically select all of the matching hole diameters, and then just pull the trigger, and very quickly you'll see that we are able to really move from a turning application into axial application with no new setup, no real major training, no wrapping. That was the term I remember in EdgeCam, where we had to wrap a lot of things. So again, very, very simple to use. Just real quick, one more profile here where we'll do the internal. I want to show you this because I want to mention the tool is defined as a type for boring. Okay, so that's how I've done this part here. You could do general turning and then just make sure that the setup is in a different direction. So there's really two different ways to do that. But for me, I just basically pick the insert, make sure that it's loaded the correct way, and you'll see that graphically here also. So we're using the profile operation, which is really basically the same thing that we used out here on the outside and the inside. So when you get into boring, really the only difference is how the tool, that's never happened before. Yeah, if it's going to happen, it's going to happen when I'm in front of people, isn't that right? Apologize for that. Sometimes I get a little click happy. While this is coming up, I'll just change gears here real quick. I mentioned to you earlier that Hagerman and Company on our website, if you go to our website and you go underneath the events pull down here is webcasts on demand. And if you pick on the manufacturing area, you'll find all of the webcasts that we're doing, including this one, which is being recorded, will be posted here. But all of the webcasts that we do are available to you on demand. And here's one that kind of focused a little bit more on the milling side of things. We do ask that you create an account. We're not going to go after you or anything. Just create an account so we know who you are, and then you can access all of these events that have been done in the past. Oh, we're back. Again, I apologize for that. I don't think it cost us too much time. So again, here the difference, click on this setup, tool isometric. I always like it better this way. That's me. This profile is the outside. This is the inside, and again, it's all the same functionality, the same menu choices. It's just a difference of how the tool is being held. And then we have a parting operation. Depending on your machine tool, we can part those off. If you want to bring in another spindle and grab it and part it off, that is an operation that we also support. Okay. I built another setup here, again, focusing right now on the axial side of things. And let me jump over and see if I was able to answer that question. Okay. So this is basically the same setup. I wasn't too worried about the stock because the part is somewhat finished. And I'm really just doing axial work right now. And I'll get into posting and looking at some G-code. So all we're doing here is really just drilling and these holes along that cylinder. And what I mentioned here, once you pick your drill tool, is this checkbox, select same diameter. So I don't have to go out and pick 8 or 10 or 100 holes. The software is going to do the work for me, okay? It's going to find all of the tools, all of the holes where the diameters match what I've selected and select those for me. We can also merge operations and control the order by depth. So this axial operation is really pretty simple. I'll just simulate this for you. Just loading a tool. First I'm going to spot drill it. And then we'll come back and we'll load another drill and we'll drill it. Okay. I then build another setup for the back side of this. Because the part obviously does have some milling operations on it. So from CAM and HSM, I'm not really switching from milling to turning. I don't have to double click on something and fire up the turning and double click on something and fire up the milling. I can do it all right from within the same user interface. So on this setup here, you'll notice that my stock is really only this back edge. Kind of see that here by this shaded area because I've already manufactured all of this. So I'm defining this as my stock. If I didn't do this correctly, just an FYI, if I was too quick and just let it build the stock over to where I've already machined, then when we go in and we start doing the profiling work, it's going to machine all the way back here, cutting a lot of air. So the setup and the stock definition is important. Okay, so your toolpath is looking at the stock. I need to make mention of that. And again, we still have the Z-axis pointing in a direction, very easy to change, either by selecting or not selecting. A lot of options for your orientation, depending on your machine type, and really depending on what geometry you have. On a round part, it might be a little difficult to pick the x-axis or the y-axis. So a lot of times I just do the model orientation and define the coordinate system and Control Z. And then X and Y follow around the Z based on the right-hand rule. Now here we're moving, well, we've been talking a lot about the turning side of it. We're still on a turning center, okay? This is still a lathe, but these other milling operations are available to us, even though we're on a lathe. So I can go to the 2D contour which allows me to create milling toolpath on a lathe. So if we double pick this, we're going to go ahead and load up a milling tool. In this case, I'm just using a 6mm flat. We define our contours that we're machining, and I'm thinking that maybe the first thing we'll do is we'll go ahead and kind of rough out this area here, and you'll see that there's an arrow showing which side I'm machining, and if I click on that arrow, I can change which side I'm machining. So from a learning perspective, that's kind of a gotcha there too. If you're having trouble getting the tool on the right side, check that arrow. Rest machining is here for you also. In this case, it's not on because that's still solid. I've selected my contour, which is basically that base right there. Define my clearances, approach, rapids, retracts. And now I'm defining my passes and my climb milling and my conventional milling. Do I need to worry about cutter compensation? In this case, G41, G42. Does the machine handle that? Do I want to have multiple roughing passes, perhaps a couple of them, depending on the stock? Do I want to do multiple depths? Do I want to leave stock later? So again, you're just answering questions here of what you know from a process standpoint of machining this part. Again, your link tab is how you get from one area to another. We're going to lead in and lead out. And if we simulate this, there we go. And again, these retracts, and this is also nice, I should have mentioned this earlier, the color coordination. You can see yellow, green, blue. This is neat because if we go back in here and look at the initial tab on the speeds and feeds area, we have a lot of options, unlike really anything I've seen before, Smart Cam, Edge Cam, etc., where I can define a ramp speed, a cutting feed rate, a lead-in feed rate, a ramp-in feed rate, and that's what those colors are showing you, different changes of feed rates. Okay. Again, we'll go ahead now and do these slots. Basically, this same type of tool, but there's radiuses on the engineering, how it was engineered. So I'm just going to load a end mill that's got a large corner radius on it. Still doing the contour operation. So again, I'm just selecting the contours. And in this case, I can see I can just pick an edge. I think if you hold your Alt key down on your keyboard, you can pick an edge. If you release the Alt key and move your mouse, it's picking all of those edges. You may not want to run all the way around with this tool. In that case, one more time, just hold down your Alt key and pick a single edge. Rest machining, we might turn that on and hit OK. And this is neat here. You'll run into this where you don't get a tool path. If you right-click on this, you can go to Show the Log, and it's showing you that there's no passive link. It's an empty tool path. So what I've done is that rest machining, if I turn that back off, now we get our tool path and it's successful. Another thing that's neat here about this right mouse button area is I can right mouse button and say view the tool path, and it shows me a list color coordinated based on feeds, or I'm sorry, it looks like it's color coordinated based on the movement type of the X and Y values that are being used to machine this. And one more neat thing in here also, if you right click, you can go to machining time. On this particular operation, it's taken 23 seconds to machine it. Okay, one tool change and your rapid distance. So let's simulate this. I'm kind of a, I tell people if you can't find something, check your right mouse button. Because the software is intelligent where it will, based on where your mouse is, give you the menu that you need when you right mouse click. All right, so let's go ahead and look at this in a little bit more detail. I have to simulate an entire operation. I can click on this and use the control key and select that to multi-select and then simulate those guys. Maybe I'll turn on the stock. There you go. We're doing some more drilling and tapping here just because the first time we just did this flange. We have a new setup now, so we need to poke holes in here. Really nothing different than I've already shown you. And then finally I want to machine this area here. And I use the contour. You'll notice here's a pattern. So I've used the contour operation that we've used before and picked my tool and my contour selection. I'm just machining one of them, okay? So I'm just going to machine one contour. Thank you. So all we have in this case is a mess. We're machining one contour and this big slab of metal is falling off. So I'm going to go in here and double click this and we'll go over to our passes tab and I'll ask it to do multiple passes. Where are you at? Oh, here we go. Sorry. And let's see what that looks like. Rough that out, and a little finished pass there. The reason I did it this way is I wanted to show you the pattern, which is sitting up here under your job. Once I created an operation, and you might use this a lot in turning environments, I can then take that operation and just like AutoCAD or Inventor, I can create a pattern of that operation based on an axis to revolve around, which is this cylinder, really anything round. It didn't have to be that cylinder. It could have been this outside shape for that matter. And then how many instances do you want, and how many are you filling a whole angle or what? And then you can also preserve the order. So if you're using multiple tools, you can define if you want to rotate based on tool or do one complete, then rotate and do one complete. So very quickly there, I was able to machine one operation and then use this pattern functionality to take care of the other two. Index. And now, just to kind of do that a little bit live, and man, time flies, doesn't it? Let me come over here. I want to go back into the model real quick. And we have an engineering change, and I'm going to attempt to, and I'm not a modeling guy here, I'm going to start a sketch based on that plane there. Put a little circle in here. And I'm going to dimension it just a little pinhole here. I want that to be 2 millimeters. And we'll finish that, and we'll punch this hole. Don't laugh at me if I've done it wrong, okay? Cut through all. Profile. There we go. Hit OK. There we go. Engineering change, right? Okay, integrated cam. So I go back to the cam environment. And that's what these little red X's mean, is that you need to just right-click and regenerate that tool path once you're satisfied that the change is being resolved. So we're good there, and we're good here. You guys care if I go a little over an hour? I don't know if that'll blow us up or not. So I'm going to go, this checkbox is the default setup. I'm going to go back to this setup here and make this the default setup. And what we're going to do is we're going to go in and we're going to punch a hole, drill. I'm going to go get a 2mm drill. This is recorded, so I apologize if I'm moving fast here. Select that guy there. And see the orientation? What I'm going to do when I move to the next tab is I'm going to change my tool orientation to have it point and flip that way. And maybe X needs to also point out. And then we're going to go ahead and drill these holes and hit OK. So I hope what you're seeing, maybe I shouldn't do it after I part. Let's move this up. See how I can drag and drop that up? So once we're doing a profile, then we come in and we drill it. And I'm going to edit that drill, and I need to push this through, make sure it gets through that hole. So I've done that. Now I want to do the other side. So again, the pattern that I discussed earlier, I'm going to select on that drill, it's highlighted, and go to pattern and tell it to do a circular pattern around some axis, and I just want 2 of them, and I hit OK. Seriously, that easy. So if we simulate this, and there you go. And then obviously, from a posting standpoint, just while I wrap this up, all dozens of posts are included with the software. It ships that way. You're good to go. This guy right here allows you to filter between what type of operation or what type of post you're looking for. So I can go and pick a Haas mill turn post, give it a number, hit post. It comes with a real nice editor that's color-coded. So you can easily see between G1s and G3s. There's a lot of functionality in this post processor that I've basically run out of time to tell you about, including file compare. And I'm going to also mention that on the Autodesk CAM site, cam.autodesk.com/posts, there's a post library that's available to you where you can filter through different types of machines and posts. And there's also a sample. So if you click on sample, it actually takes you and spits out some sample G code for you. The cam.autodesk.com site. And let me check your questions real quick here. Okay, no more questions. If you have anything after you view this, just let me know. My fear here is in 1 minute we're all going to get kicked off. So I kind of picked up the end. I apologize for that. But I hope you found this valuable. It was recorded. We'll post it for you. But keep in mind, we know manufacturing here at Hagerman & Company, we can do custom training classes for you. We run a lot of them over the web, a day, a half a day, depending on your needs. It's not a big investment. It's not a lot of time. So we're basically here to help. Ashley, you want to grab it and close us out, please?
Yes, thanks, Tad. As Tad said, if you think of additional questions, you can simply reply to that reminder email you received from GoToWebinar, and we can route those to Tad and get those answered for you. Once again, if you could take a few moments to answer the survey, we would appreciate it. It will just pop up as we close down the session. And other than that, thanks for attending today's webcast, and have a great day, everyone.